Okay, we're going to review greatest common factor. And so let me find you some problems with greatest common factor. You may just go to our packet. Here we go. Okay, when we factor quadratics, and we're going to do that in a minute, the top of your report, your packet says factoring trinomials, but the trinomials we're going to be working with are quadratics. If you'll remember, quadratics, their largest power or their degree is 2. And those are the normal ones that we'll be factoring. Okay, and then the first step in factoring any polynomial is to find the greatest common factor. So let's review a couple of those problems, finding the greatest common factor. Let's look at, here's an example, and it came off the front page of your packet. It is number 14. Okay, factoring out the greatest common factor means what I want to do is look at each term and find out what the largest number is that I could take or divide out of this term, and this term. Now we found out if it's something that you have a hard time seeing, we found out that there's a way to do this, okay? So I want to show you that way first. So if we break this down, we have 2 times 1 and P times P. This one, we'll do our prime factor tree. We have 2 and 7 and a P. And this one, we have 2 times 12, 2 times 6, 2 times 3. Now, the greatest common factor is going to be every piece, every little factor that matches in all 3 pieces. So to show you what I mean, here's a 2 and a 2 and a 2. The number has to be in all 3 places. And so I have a 2. Of course, the 1 is always going to be there. I have a P and a P, but there's not 1 here, so I can't use the P. I have a 7 here, but no 7s here. I have a 3 here and no 3s here. So the greatest common factor in this problem itself is simply 2. Now, when you find the greatest common factor, then what we're going to do is show how we divide it out of each piece. This is going to be very important in your factoring process. So we said our greatest common factor is 2. Now what we're going to do is show that I am going to divide this polynomial. I'm going to divide 2 out of every piece of that polynomial. So if I take 2p squared and divide it by 2, then 2 divided by 2 is 1. I have 1p squared. We leave the 1 as an invisible 1 plus. Now I need to take up my 14 and divide 2 out. So I have 7, and I didn't divide a p out here out front anywhere, so the p is still left. Plus, now I had 24, but I chose to divide it by 2, and I have 12. This is factoring out the greatest common factor. Sorry, I was standing in the way. This is how we factor out the greatest common factor. I showed you how to find what it is, and then how to show that I divided the greatest common factor out, and what is left here is another polynomial. Later on, here in just a few minutes, I'm going to show you how to factor this. But right now, I want to show you a couple more finding the greatest common factor, because I'm telling you in the steps, and you should have received this list about factoring quadratics or factoring polynomials. You should have received a little list to go by in your email. This is of great importance to always do this first. Always take out the greatest common factor. Let's try another one from your worksheet. I want to go to, I am going to use one, but I'm going to modify it so I can show you something. All right, let's do this one. Okay. All right, when I look at this, I'm going to try to stay out of your way. When we look at this, we want to decide what the greatest common factor is. Some of you can see it. I'm going to go ahead through the process. I have 2 times 2, x times x times x. And then I have 2 times 8, 2 times 4, 2 times 2. And x, x, this is a minus, so I don't want to mess that up. And then I have 6 times 8, 2 times 3, 2 times 4, 2 times 2, and x. Now we found out that if I can find a match in all 3 pieces, then I can put that up here with the greatest common factor. And so usually the 2's are what show up. So I have a 2 and a 2 and a 2. Mark these out as you put them up here. That way you won't end up counting one of the numbers a little bit too many times, okay? So I crossed out a 2. Let's see, I see some more 2's. So here's a 2, here's a 2, and here's a 2. So there's another 2, and here's a 2, and I can't mark out any more 2's. I started to mark out this one and this one, but there's no more 2's to match here, so I can't have another 2. Now, if you look at the variables, they count the same. So I have an x and an x and an x in the same, in each piece. So I also have an x that I'm going to add to this greatest common factor. Okay, this is not 22x. When I've got all my matches, I need to multiply these, which means my greatest common factor now is going to be 4x. Now that we know what the greatest common factor is, let's factor it out. Okay, so I said the greatest common factor is 4x. That's what I'm going to write out front, because that is what I'm going to divide out of every piece. Okay, if I had a 4 here and I want to, this is the original, and I want to divide a 4 out, 4, the original 4 divided by 4 is 1. We use it as an invisible one. But also look, I had an x times x times x here, and I divided an x out. So now I only have x squared left. Do y'all understand what I'm putting here? Yes? Okay. And then we use the signs that were given, a plus. Now I had, the original was 16. I want to divide a 4 out. I've got to take this 4x out of each term. So I had 16 divided by 4 is 4. But make sure that you're taking an x out of here. Now this was x times x, but we took 1 out. We still have 1 x left. 4 x's minus, and one more time, we have 48 divided by 4 is 12, and x divided by x, that means I divided that x out, so I have no x here. So this is what we have when we take out the greatest common factor. And on this worksheet in your packets, you're going to be doing this over and over and over again. The top part doesn't tell you to do that. The bottom part will start to help you practice taking out greatest common factors. So don't forget about that. We're going to move on to how you factor trinomials now. After you get the greatest common factor out, we're going to learn how to factor this. So I'm going to go back to the front page and actually work some of the problems there. Now, as you move through the steps of factoring, just like I said, finding the greatest common factor is the most important. The second step, and you should go in this order, the second step says to look for specials. We'll talk about that later on in the week. But specials only have, the ones I'm talking about only have 2 terms. So if you have a polynomial with 3 terms, it's not a special. Then the next one you look at, you're going to look for any grouping. Now that's a special type of factoring that we're going to do. But if you have a grouping of polynomial, then it has 4 terms. So if you only have 3 terms, it's not a grouping. So you move to the next step. And the next step is what we're going to practice a lot today. Okay, is factoring into 2 parentheses. Let me find, we may just start with probably the first one. Let me see here. I think I would like to go, this uses everything but x's. I'm going to use this example right here. It's not on your worksheet yet. Now I'm going to go ahead and tell you a clue because I want you to get used to, as soon as it says to factor something, you say, oh, I got to look for greatest common factor. Have to look for greatest common factor. Now, a shortcut that I've found over the years is if the leading coefficient is an invisible 1 and there's no variable at the end, there's probably not going to be a greatest common factor except for 1. All right. So in this case, the only greatest common factor is 1 and we don't deal with that. So I'm looking, step 2 says to look for specials. Well, specials only have 2 terms. This has 3, so there's no specials. Step number 3 says to look for grouping. Grouping has 4 or 5. Okay, we're going to find out. Or 6. 4 or 6. But this only has 3, so there's no groupings. So we're going to move straight to trying to factor this into 2 sets of parentheses. Now, if you look back at YouTube, in the week before our spring break, we talked about this once, but after spring break is a good time to do it again. So here's the way I teach this all the time, and it seems to work. When I talk about the front and the back of something, I'm talking about the left-hand side, like you start here and read like a book. So this is the front and this is the back, okay? So you won't get mixed up. So the front, whatever you put here, times the front, whatever you put here, has to equal the front. So the front times the front has to equal the front. So, of course, x times x equals x squared, yes? Then I have found out that if you put an actual literal box around the middle term, including the sign, that this helps a lot. Let's go to the end term now. What I put here times here is going to give me 15. The back times the back equals the back. Now, this time, I don't have a whole lot of choices, but you should always list all the factors. Actually write them down. I start with 1, 2, 3, 4. Okay, so 1 times 15 works. 2 doesn't go into it. 3 times 5 makes 15. I'm going to go in order. So 4, does 4 go in here? No. And my next one is 5. Now, since I have already used a 5, I know this is it. That's all of them. Okay, this is how you make sure you don't leave any factors out. Now, what you need to do is look at this pair or this pair and see which pair would add or subtract to your middle term. Notice that the 1 and the 15, if you added them, you get 16. If you subtracted them, you get 14. So that won't work. I need 8. But if you add the 3 and the 5, you will get 8, right? So 3 and 5 are our numbers that we put in the back. Okay. Now, there was something I was going to tell you. Oh, since the front is exactly the same, later on in your factoring, these will be different. Okay, but now since this and this are identical, then it doesn't matter where your 3 and 5 go. Okay, 5 could go here, 3 could go here. Now, the way that you test and decide what the signs are going to be is you multiply the insides. This is just the test. And you multiply the outsides. If you forget what to multiply, to me, this looks like a heart. Okay? It's an easy way to remember which ones to multiply. Now, I need this 3x and this 5x to be put together some way to get a positive 8x. So now you're going to have to remember about your signs. Are they going to be both positive, both negative, or are they going to be opposite signs? Okay. In this case, to get a positive 8, you're going to have a positive 3 and a positive 5. When you decide what the signs are here, you just bring them up and put them in. So with all of that work, this is your answer. This is your answer. This is the factored part of this trinomial quadratic. Okay, this parentheses right here, x plus 3, is one of the factors. X plus 5 is the other factor. So there are 2 factors to this. Okay, there are not 1, 2, 3, 4. First parentheses is 1, second parentheses, this has 2 factors. Well, this is the first time you've seen it, okay? And a shortcut for the signs, the other signs won't be so easy, but if they're plus and plus, they're going to be plus and plus. but don't do that on the others. Okay? Because minuses and minus won't be minus and minus. Okay, let's do another one. Are there questions so far, Sherry? Sherry, are you trying to hang on?
Yes, ma'am. I'm listening. I'm fine.
But you're okay for now?
Yes, ma'am.
Okay. Let's do this one. Yeah. X squared minus 6x minus 27. Okay, and it says to factor these. And what you'll see as instructions is factor the quadratic, factor the trinomial, factor completely, but factor is the main word here. So we're going to look for a greatest common factor, but we found out if this is an invisible one and there's no variable here, probably not a greatest common factor except for one. We look for specials. Special has 2 terms. This has 3. We're going to look for groupings. That has 4 or 6 terms. This has 3. So it's not a grouping. So we go straight to 2 parentheses. I encourage you to always go through this. Always go through this. If it seems like the same over and over again, someday it won't be. So use those 4 steps in order. So the front times the front gives us the front. Don't worry about signs until the very end. We box in the middle term, remember to use the sign. Then we look at the back and we say, okay, I have to know all of the factors of 27. So I start with 1 and 27. 2 won't go into it. 3 times 9. 4 won't go. 5 won't go. 6 won't go. 7, 8. The next one is 9. So these are our only factors because I've already used a 9. Now I need to look at each pair and decide if it will add or subtract to get me a 6. So we see that 3 and 9 is the pair that we're going to work with. And again, since the front is identical, then the back, it really doesn't matter where these go. Now we're going to test it to decide on the signs. And I need a negative 6x out of this. So I know that I didn't add these, right? That would be 12, whether it's a positive 12 or a negative 12, and that's not going to work. So I'm subtracting. That means the signs have to be different. One of them has to be a subtract. This tells me the largest one has to be a subtract. So there's the largest one. These are the signs that they need to be. 3 minus 9 is a negative 6. So if we go up here, the 3 is positive. We go up here, the 9 is negative. Remember, with all the writing that we put everywhere, this is the answer. This is the factored form of this quadratic. Any questions?
Yes. That where you said figuring out the sign, I'm kind of lost in all that.
Okay, because it's negatives and positives again.
Okay, so we take, let's see, the 3.
I always multiply here, or do you have a problem with that?
Oh, okay. Okay, so
I multiply the outsides and put it here.
Okay.
Without the signs. And I multiply the insides and put it here without the sign. So I had a 3x and a 9x, and I've got to figure out what signs go where so that when I put this together or add it, it comes out a negative 6. Now, if you still have trouble with your negatives, then what you need to do is just trial and error and put it in your calculator.
Now
If
I
you-
know how to I know how to do the positive and negatives. I just got lost in the steps of what to do.
Okay. Yeah, use your calculator for a while.
Okay.
Now there is a shortcut, and I've made mention of it a couple of times before spring break. These signs are actually a code to tell you what signs go here and where they go. When I feel comfortable, I will tell you. Right now, you need to go through this process. All right? So the negatives and positives is your problem, Sherry.
No, I know how to do the negatives. I know how to do the negatives. It was just I got lost in the steps of what to do.
Oh, how to get these?
Yes.
Yes. Okay, let's try one or two more, and then I want y'all to start practicing, okay? Now, there are parts on every page that we're going to deal with tomorrow, I think. I'll look at them. Let's do another example here right off of your worksheet now. I decided to go back to your worksheet again, and we'll do number 1. With the P's there. P squared plus 14P plus 48. Okay, again, quickly through the 4 steps. There's no GCF except for an invisible 1 because all I have is 1 and no variable here. This isn't a special because it has 3 terms, not 2. It's not a grouping because a grouping has 4 or 6. So we're going to go straight to step number 4, to the 2 parentheses. The front times the front gives you the front. So I have P times P. Then I box in the middle term. I need all the factors. So I've got 1 times 48, 2 times 24, 3 times 16, 4 times 12. 5 won't go into it, 6 will. 7 will not go, and my next number is 8, and I've already used it. So this is all of the factors. So I need to find which set is going to give me 14. And I see that it's the 6 and the 8. So I put a 6 and an 8 in the back because the fronts are identical, so it doesn't matter. And then I'm going to test these, but we have already seen just a shortcut. If it's plus and plus, it's going to be plus. Now let's look at it. 8P, 6P, and I need a positive 14P. So the only way that's going to happen is if I add these together. That means this has to be positive and that has to be positive in order to add those together and get 14. So I've got a plus and a plus. That's the only time you can do this. Questions here? And again, your factored form is right here. If you multiplied this back out, multiplying binomials, where you do FOIL, you would come up with this quadratic right here. This is just where we divided it up. This is where we multiply it back together. Okay, let me look at this worksheet and see if I have any instructions for you. From what I've shown you today, page 1, you should be able to do it all. If you look at the top part, you don't have to take out greatest common factor. But if you look at the bottom part, it says factor completely. Remember to pull out the greatest common factor, which means they fixed it, so you're going to have a greatest common factor. you should be able to do all of page 1. Let me look at page 2 and make sure. And it looks like they didn't tell you which ones, but most of these is just practice factoring. And then right at the end, starting with 16, 17, where's 17? Huh. They left out a 17. That is so funny. Okay, 16, 18, 19, and 20 is where you have to be careful to look for greatest common factor, because notice that it's not an invisible 1 as a leading coefficient anymore. So that gives you a clue there might be a greatest common factor. Okay, so you should be able to do all of page 2. Now, I noticed one of the students noticed and called to my attention that the second page doesn't have an answer sheet at all. So what I did yesterday is made out an answer sheet, and I emailed that to all of you that are remote. And it's here in the classroom for anybody that's here in the classroom. So Sherry, you might want to check your email for that answer sheet on T2. Okay, on that second page that doesn't have an answer, any answers. Okay. The front part of page 2, you should be fine. The back side of T2, you cannot do yet. Okay, so what you're going to do is T1. You're going to do page 1 of your worksheet. This worksheet actually has a front and a back. You only have enough information to do the front. So those are the 2 pages that I want you to do. We'll begin tomorrow with the back of T2. Any questions?
Okay, so I didn't get my papers numbered. Okay,
Oh,
so,
okay. You want to see it again?
so
This one is T1. And the way I keep track, I'll look up here at what number 1 was. Okay. So this page right here is T1. You should be able to do all of that page. T2 starts with this problem. And you should be able to do the front part, the front page of this sheet.
okay.
And that's all this time. And you should have received the answer sheet for this one.
Yes.
It wasn't included in your first email.
No, I got it. I didn't know what it went to, but I got it.
Okay, work those 2 pages. You should have enough information for those 2 pages. Any questions?
Okay.
Sherry, are you going to want to stay on, or are you going to want to call me with questions?
I'll probably stay on.
You're going to stay, you said?
Yes.
Okay, works for me. That's all I have for today.